Hello everyone. In this video we'll learn the monotonic functions and the first derivative test. So what is a monotonic function or monotonicity theorem? It's all about the function in which the derivative is positive or negative, the function increasing or decreasing. So for example, let's think about the x squared function. That's an x squared. So x squared function, if you notice that from here all the way to here, from negative infinity all the way to 0, the function was decreasing because the slope was negative, right? So this is a decreasing, so the function was decreasing over the interval from negative infinity to 0. And then the function is increasing from 0 to infinity. And you need just to know that it's all about the derivative of the tangent line. And the derivative of the tangent line is basically the first derivative. So if the first derivative is greater than 0, then the function is increasing. And if the derivative is less than 0, the first derivative, then the function is decreasing. So that's everything basically about the monotonic functions. So in these questions we need to tell the intervals in which the function is increasing, decreasing, and then find the extreme values. So let's start with the first question here. gt equal negative t squared minus 3t plus 3. So as we know, to tell whether the function is increasing or decreasing, we need to find the derivative, the first derivative. So g prime of t equal negative 2t minus 3. Make this equal to 0 to find if there is any critical points. So g prime of t, make it equal to 0. That means negative 2t minus 3 equal to 0. And t will be equal to negative 3 over 2. So at g prime of negative 3 over 2, the function was equal to 0. So now I need to draw a number line to study the sign before this point, negative 3 over 2, and after. So how do we study the sign? Well, we need to take any point in here. So let's take, for example, negative 2 maybe. So if you try to substitute by negative 2, g prime negative 2 equal negative 2 times negative 2 minus 3. That's equal basically to 1. So it's positive. The derivative was positive to the left side of negative 3 over 2. Let's take any point after negative 3 over 2, maybe 0. So g prime of 0 will be equal negative 2 times 0 minus 3. That's equal negative 3. So it is actually negative. So what happened? The function was increasing and then it decreased. So what we are going to say here, we'll say, so gt is increasing over the interval negative infinity comma negative 3 over 2, or maybe you can say when t is less than negative 3 over 2, gt is decreasing over the interval anything greater than negative 3 over 2. Now then they want us to find the extreme values. Well, as you can see, I just have one extreme value, which is here, and it's maximum, so this is an absolute. So I have an absolute maxima at t equal negative 3 over 2, negative 3 over 2, comma, I need to find the y coordinate. So I'm going to go to gt, find g negative 3 over 2. By making the substitution, I'm going to get 21 over 4. So 21 over 4. So basically, if you would try to use GeoGebra or Desmos to draw this function, you're going to get something like that. in which this point here is basically negative 3 over 2 and 21 over 4. Okay, so now we're going to do the same thing. Again, we need to find the intervals of increase, decrease, and the extreme values. And in order to find these things, we need to find the first derivative. And then make it equal to 0. So I have 2 critical points. Now I'm going to draw a number line. Study the sign in here, in between them, and at the end here. So just take any random points. You can take, let's say, for example, you can try h prime of -1. Here you can try h prime of 1 maybe, h prime of, let's say, 3, 4, 10, whatever you want. So let me take 2, for example. So now, if you try it, you are going to get the following. So I care only about the sign, so you are going to get negative, positive, and negative. So basically, this is negative means decreasing, positive increasing, and negative decreasing. So I do have here and here points. Now, are these, let's first of all talk about the increase and decrease. So hx decreasing over which intervals? From negative infinity to 0, union 4 over 3 to infinity. And it is increasing over the interval 0, 4 over 3. Now, what about the critical points here? Well, I do have, this is a minima. Now, is it local or absolute? Well, it is local because the function goes down. So there is something lower than this point. So I have local minima, and also same with the maxima, local maxima. Local minima at the point 0, comma, maxima 4 over 3, comma. Now, in order to find the y-coordinate, you will go here and find h0. h0 equal basically going to be 0, and you will find h4 over 3, and that's going to be 32 over 27. And as you can see, no absolute maxima or minima, because the function coming from up all the way down. The graph of the function will look like something like this. Goes down, up, and then down again, something like that. Okay? Now, what about this question here? 3r cubed plus 16r. So same, we are going to do the same thing. We will take the derivative, first derivative, make it equal to 0, and then try to solve it. Take a square root. So now this is an error. What does that mean? No critical points. No critical points. That's one thing. So what does that mean when there is no critical points? That means in the whole function, the function all over the function was increasing or decreasing, entire function. So the domain here is all real numbers, right? That's a polynomial, so the domain is all real numbers. So if you take any number, 0, I prefer to take 0. You can take anything and you substitute f prime, let's say of 0, or f prime of 1, or maybe f prime of negative 100 or negative 10, you will always get a positive answer, always. So what does that mean? fr, the function, was increasing over its domain. And what is its domain? From negative infinity to infinity. What about this question here? A rational function. Well, for any rational function, the denominator cannot be equal to 0. So in this case, x cannot be equal to 2. The domain is all real numbers except 2. So the function itself is undefined at x equal 2. I will be having a vertical asymptote. What does that mean? The derivative also will not be defined at 2. Now, let's try to find the derivative. When you find the derivative, you will take this as a u, this as a v. So u prime v minus uv prime, and you are going to get x to the power of 2 minus 4x plus 1 over x minus 2 squared. You will make it equal to 0 to find the critical points. And when you cross multiply, you're going to get x squared minus 4x plus 1 equal to 0. And that will give you x equal 3.7 and x equal 0.3. These are going to be my critical points. Now at 3.7, the function, if you substitute and you try to find f 3.7 here, put 3.7 instead of x, you will get 0.5. And here 0.3, you will get 7.5. So these are my critical points. Now we can draw the number line from 0.3 and 3.7, and never forget the asymptote. And I like to draw a Brocken line here. Study the sign of f prime of x over the interval. So remember, f prime of x is equal to x squared minus 4x plus 1 over x minus 2 squared. So taking any number here, you can take, let's say, 0 and find f prime of 0. If you found f prime of 0, calculate it, you will get a positive here. And if you take any point between 0.3 and 2, you can take 1, for example, you are going to get negative sign. And if you take anything between 2 and 3.7, like let's say 3, you can find f prime of 3. You'll get negative. We care about that sign only. Finally, after 3.7, you can take, let's say, 4, 10, 100, you'll get positive. So a function was increasing here and then decreases. And there's a vertical asymptote, so we're not going to touch that. Decreasing and then increasing again. So now you can say the intervals of increase, or the function is increasing between negative infinity to 0.3. You can say union or comma 3.7 all the way to infinity, decreasing from 0.3 to 2 and 2 to 3.7. Now what about the extreme values? Well, in this case, if I try to draw in the function here, this is 2, and I will have also, that's what you might think about, since the degree here is more than this one, I will have oblique asymptote actually somewhere. It will be somewhere here. Now if I draw the function, it will be here and here. This point here and this one here, this is going to be 0.3, this is going to be 3.7. So this point, as you see, is a maximum point. It's a maximum, you can see it here. But it's not an absolute, so I have a local max at 0.3 and 7.5. And I do have a local minima, so local maxima at 0.3, 7.5, and local minima at 3.7 and 0.5. Okay, and my critical points are 0.3, 3.7, and 2. 2 is a vertical asymptote. Now, what about if I added a question here? Let's say fx equal x minus 6 as square root of x minus 1. First of all, I need to think about the domain of this function. Well, for any radical function, this whatever inside the root should be positive, 0 or positive. So x should be greater than or equal to 1. So what happened? If I will draw a number line, the function is undefined on the negative on the left side of 1. So the domain is going to be from 1 to infinity. Now let's try to find the derivative, to find the critical points. If you try to find the derivative, it will be 1 minus 3 over square root of x minus 1. You can make it equal to 0 and try to solve it. You will do cross multiply here. You will have square root of x minus 1 equal 3. You can square both sides. So x minus 1 equal 9 and x equal 10. That's my first critical point, basically. So at this critical point, what happened? At x equal 10, f prime of 10 equal to 0. What about 1? Look here, what happened? 1 came down, so x cannot be equal to 1. So at f prime of 1, the derivative does not exist. So I have critical points where at x equals 10 and x equal 1. So I have two critical points here. So if I draw a number line, I'm going to start from 1 here, and whatever left does not exist. There's no function on the left side. And then I'm going to have 10 here. So, and then I will study the f prime sign. And remember, f prime of x again equal to 1 minus 3 over square root of x minus 1. Take a point from 1 to 10. You can take 2, substitute it in the function. You will get a negative sign here. And then after 10, you can get positive. So what happened? The function was decreasing and then increases and continue increasing. So I have an increasing or decreasing, let's say first, from 1 to 10, and increasing intervals from 10 to infinity. Now what about the extreme values? If you try to draw the function here, it will come like this. So basically this is 1 and this is going to be 10. So this one is a maximum point, but it's a local max at x equal 1, and if you substitute 1 in the function, you will get 1. And you have a local, and you will have this one here. It's an absolute minima at 10 and negative 8. Okay, guys, 10 and negative 8. So that's a local max, that's an absolute minima. Now, some people will say, oh, but the function is undefined here. Well, the derivative is undefined. However, the function was defined at 1. It's different than this one here. The original function was undefined and the derivative was undefined, both of them. So even if you came out like, for example, if you end up with, this is 2, and it was increasing and then decreasing, we cannot consider this an extreme value because the original function was undefined. However, in this case, the original function was defined. Okay, so that's everything, guys, for this lesson. Please let me know if you have any question, and see you next class. Bye bye.